Oh,
Okay, so we will go over our homework. There was charts and graphs and some mean, mode, median, range problems. And we'll look at some more graphs and charts, and then we'll go into radicals and exponents. All right, so let's look at the homework. Maureen, did you do any of your homework? Maureen?
I know, Miss Barbara.
Okay, so let's do our
I,
homework.
I was there for something coming Tuesday night. I was looking for some paper that was the doctor thing.
Right.
I can't go for the looking all today. I had a day, so today and every day. Yeah.
Okay, that's right. You just got back from Barbados Tuesday, right?
Yeah.
Okay. You had a good trip? I'm sure you did.
Yeah.
Didn't want to leave, right?
Exactly.
Your brother treats you good, right?
Yeah.
Okay, let's look at the first graph. Now, what kind of graph is that, Maureen? What kind of graph is line graph? Very good. This is a line graph. And it's showing the high temperature in Zanesville for the week of November 2nd. And notice how the temperature goes up, temperature goes down, temperature goes up again, temperature goes down. Now, Maureen, see if you can answer this question. Now, of the days shown, between which two consecutive days did the peak temperature decrease the most? Now, you see the graph. Which 2 weeks would you say? The weeks are on the X line, the X-axis. Temperatures is on the Y-axis. Between which two consecutive days did the peak temperature decrease the most? What would you say, Maureen?
I would say, I can't even see it though. You got to break that higher.
Are you on your phone or you on your computer?
On my laptop.
You can't see this?
I can see, I can't see the, I can see like, it's Sunday.
You see Sunday? You see the dot here?
Yeah, I see
That's
Sunday.
Monday is there. Tuesday is here. Then Wednesday, the dot, we just bring it down. There's Thursday, there's Friday, there's Saturday. So you have choices between Wednesday and Thursday, Friday and Saturday, Tuesday and Wednesday, Monday and Tuesday. So which one will you pick to show the largest decrease? In other words, the temperature went down.
And it says Thursday.
Which 2 days would you say?
Wednesday and Thursday.
Wednesday and Thursday. Remember, I say you looking for what? Where it decreased the most. In other words, the largest decrease. So look at 2 days and look at where the dots are and tell me between what 2 days was there the largest decrease? So what would you say, Maureen? It's not the one you said. It's not Wednesday, Thursday. How do you know there's a decrease when you look at this line graph, Maureen? What indicates a decrease?
When it goes up and come down.
When it goes down, right?
Yeah.
In other words, the graph, you're going up, down, 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 up, down. Now, notice on this X-axis, you have the days: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So look at the days, Look at where the next dot is and tell me which one showed the largest decrease. Which pair of days showed the largest decrease? The largest drop.
Friday and Saturday.
Friday and Saturday. Well, that's a decrease, but remember, you're looking from one point to the other. So the greater the distance between the points, then the greater the increase or decrease. So look at the dots. Which 2 days have the longest space between the dots for a decrease?
Monday and Tuesday.
That's it. That's it, Maureen. Because see, Monday to Tuesday, that's a longer drop than, say, Tuesday to Wednesday, because the line is longer, right? It's longer than Wednesday to Thursday. Thursday to Friday is an increase. Friday to Saturday is a decrease, but that space, that line there between those 2 points is a lot smaller than the points Monday and Tuesday, right? See how you figure it out? So what would be the answer, Maureen? A, B, C, or D?
D.
What would it be?
D.
D, that's right. Answer D. I was hoping Mercedes would come on because she answered that one, but she picked a different, like you did it first. She picked a different consecutive days. So you can see this line is longer, right? Longer than any other decrease, longer than Monday to Tuesday. Monday to Tuesday is longer than what? Tuesday to Wednesday, Wednesday to Thursday, and of course, Thursday to Friday is an increase. It went up. And then the decrease Friday to Saturday that line is a lot shorter than this one. Okay. Maureen, you understand now how you find it,
Yeah.
right?
Yeah.
Now, number 2, Maureen, read number 2 and tell me what you think the answer is.
What type of graph shall be the most useful to show changes in the quality over time?
Okay. So which one you say, a circle, line, bar, or pictograph? Which one?
Let's see, the quality time. Graph.
Which one?
D.
Say it again.
D as in down.
No, pictograph. No, pictograph is the picture one, remember?
Oh,
Well, we just looked at one. We just looked at it right here. Changes over time, right? Changes of temperature over time. The time here is in days, right? So the answer would be a line graph.
oh,
Line graph. Useful in showing changes in a quantity over time. Time could be in minutes, hours, days, years, okay? That's the line graph. Now, number 3, Maureen, read number 3, tell me what the answer is.
what type of graph use pictures to represent a certain number of items? Number C.
That's it, very good, pictograph. We looked at some of those with the pizza, right? So answer C. Those are, the pictographs are kind of interesting, right? Because they give you pictures, symbols to represent items. And it's a kind of neat way of determining what's going on with things that you're graphing. All right. Now let's go to number 4. Well, there wasn't a number 4, actually. I skipped the 4, we went to 5. But 5 was based on, what kind of a graph is this, Maureen? Would you call this, let's go back up to graph. Is it a circle, a bar graph, a pictograph, or a line graph? What would you call this one? This graph.
A bar.
That's it, bar graph. And bars can be horizontal, like here, or they could be vertical. And we'll look at some pictures of both, all right? So here you have the graph. Here you have the table. So what you see on this graph is in the table. And how do you
Yeah.
know that, right? From 0 to 9, okay? 0 to 9 in the table is what, Maureen?
23.
23. And look at the bar. At the end of the bar, there's a 23. Same thing. Let's look at 40 to 49. 40 to 49 is 112 right here in the table, and it's 112 on the bar graph. So what you're seeing in the table was plotted on a bar graph here. Okay, so bar graph means they're bars. And as I said, they could be horizontal or they could be vertical. Here they're horizontal. Now, Maureen, look at the table. Whichever is easier for you to look at to figure it out. I think the table might be easier. Now, a pass in this exam is a mark 40 or more. Notice you have marks in this column, mark ranges, and you have the number of the students that fell within these mark categories. All right. Now, if 40 or more is a pass, how many students in this high school fail to pass this math exam? How would you figure that out, Maureen? Just tell me in words how you would figure out how many students did not pass this exam, and 40 or more is the passing mark.
We add up all numbers.
Add up all the numbers. Think about it now. We said 40 or more represent a passing mark. We are trying to find how many students did not pass. So what would we add up, Maureen? What ranges of marks would we add up?
1, 2. Okay.
What ranges would you add up? What mark ranges would you add up?
I would add up 112 and 128.
No, Maureen, listen to me. I said 40 or more pass. That means
That's 40
these,
to 42.
well, all these would be passing. I said 40 or more.
40
So
to 49.
these ranges from 40 to 49 to 90 to 99 would be all passing scores. All right. So how would you find the total of the students who did not pass?
Okay, so we add up from the 40 right down. And then divide it.
No. Why would you divide? Think about it, Maureen. 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99 are all passing marks. So these are all the passing, right? From 40 to 49 down to 90 to 99. Now, what would be the categories that you would add to get the ones who did not pass?
By adding top numbers.
So tell me, what would you add?
23,
Okay,
32, 45, and 67.
that's it. Very good. So add those up. Okay, add those up. 23. Let's go here. Okay, add 23 plus, let's go back up here, 32, 45. Are you adding those, Maureen? And 67. And what do you get when you add those?
167.
167. There you go. So what will be your answer?
If
A. So you see, you only had to add them up, Maureen. No dividing, no multiplying. Okay, just add up all the scores that are under 40. So the 30 to 39 is under 40, the 20 to 29, 10 to 19, 0 to 9. All of those are under 40. You got it?
yeah,
So let's just look at your table. 40 to 49 down to 99, 90 to 99, all passing. So anything above 40 to 49 would be a failure of the test, right? So you
yeah.
just add up these four numbers and these four ranges and you have your answer. You got it?
Yeah.
Now, if we said how many students passed this exam, score for passing 40 or more, just tell me in words what you would do, Maureen.
Okay, can you repeat that again?
Yes, tell me in words. My question now is, how many students in this high school passed this mathematics examination?
Yeah.
Just tell me in words. I don't want you to figure it out in terms of a number. Just tell me how you would solve it. What would you add up?
I would add up from 112, 128, 31, 19, 6, and 3.
Very good, because all of those are passing. So you just have to add up from 40 to 49 down to 90 to 99, and that will give you the total number of students who pass. Got it?
Yeah.
Very good. Okay. Now let's go to number 6. Now, number 6 is looking at the same table. Now, which of the following mark intervals contain the highest percentage of students who sat for this exam? Now, let's go back up, look at our numbers. Now, which category, which mark range would you say have the highest number of students who took this examination?
50 to 59.
Very good, 128. Because when you add up everything and divide 128 by that number, you get the largest percent. The largest percent will come from the largest number, 50 to 59. And that would be what answer, Maureen? B, that's right. Very good. Okay. Now, Maureen, which would represent the lowest percentage? Let's go back up here. Which would represent, you say that represents the highest, 128. Which would represent the lowest? Now
90,
we asked the highest percentage,
90 to
which
99.
that's it, 90 to 99, because that's a 3. So 3 divided by total will certainly give you the lowest percent. Okay, very good. Now our last category, mean, mode, median, and range. This should be median. All right. Now we had one before that had plus and minus numbers, and you had some problems with it. So I gave you another one to practice. Now, tell me in words, Maureen, how would you find the mean? Gloria made some investments. Some lost money, some gained money. The investment amounts are plus 9,000, plus 6,000, plus 7,500, plus 12,000, minus 2,000, minus 3,200, minus 4,500, and minus 1,000. Tell me in words, Maureen, how would you find the mean?
By adding all the numbers together
Adding all the and doing what? What else?
and then dividing it by the number of 1, 2, 3. And then dividing it by 8.
Divided by 8. That's right, because there are 8 different amounts. Okay, Maureen, I want you to add those numbers up. Remember, you have pluses and you have minuses. So I want you to add these numbers. All right. Over here.
And then 9,000.
Yeah, I want you to add them up. Tell me what you get.
Okay, 9,000.
Now, let me suggest you add up your pluses, then add up your negatives. Then you know what to do with your, when you have pluses and minus. You remember your rules of signs? What do you do when you have plus and minus? What do you do, Maureen?
You do the minus first.
No, no. You're going to add up all your plus numbers.
Yeah,
Then
that was
add up
it.
all your minus numbers.
I know, yeah.
You'll have a total of plus numbers and a total of your minus numbers. What do you do with
Yeah.
those numbers?
Yeah, add them together.
Add them together, which means you're going to subtract, right? So
Mm.
add up all your plus, add up all your negative. Tell me what you get.
Okay.
Let me put what you're adding here. Okay, so you're adding 9,000. Plus 6,000. Plus 7,500. So you added that up. You tell me what you got. And then we'll take out 2,000. And we'll take out negative numbers.
Mm. The first one with the added get hooked 34,500.
Okay.
And the second one, they get 10,800.
Okay, so we got 2,000, 3,200 minus 4,500 and minus 1,000. Okay, all of these are dollars. Okay, let's put our dollars on there. Okay, Maureen, what did you get for your first total?
First seven is 45, 34, 500. Let's stop the other one. And the subtraction is 1080. 10,800.
Okay, so you got 30 on this one. What did you get? Say it again.
34, 500.
Okay, 34, 500. And what did you get for your negative?
10,800.
And this is a negative. And the first one is a positive. So let's put the negative here. So you know this is a negative. Then what do we do with those two numbers, Maureen? You've added
So
up your
we sub-
positive. Go ahead, I'm sorry.
so we subtract them.
Yeah, you subtract them. So let's just put what you got here. The 34,500. Let's put the minus 1,800. Put it underneath here. Okay. Okay, now we're gonna subtract them. So let's draw a line. What do you get when you subtract, Maureen?
Okay. So 23,700.
What did you get?
23,700
Okay, plus or minus?
plus.
Okay, plus. So that's right, because you have no plus and minus. When you subtract, you said you got, say it again, the number?
23700.
23700. Okay, and of course that's dollars because you started with dollars. Okay. So you got 23700.
Yeah.
Line these up. Okay. Now that's the total when you added up all the investments. Now, Maureen, what do you do with that total?
We divide it
By what?
by 8.
That's it. Very good. So your mean would be equal to this 23,700. And you say you divide it by 8 because that's how many investment amounts you had, right? So you divide that by 8. Let's put that there. And what do you get, Maureen? Did you divide it out? What did you get? What does that give you?
23700 divided.
What do you get?
I get 2962. I get 2962.5. 2962.5.
Okay, you got 34.5. There's an error somewhere. Now, when you added this up, isn't this 107? Shouldn't it be a 7? You said an 8.
Huh?
When you added up your negative, you said 108. Isn't that 107? Shouldn't that be a check your math? I think that's 107, right?
Yeah, yeah.
Yeah, because you see there are 5 and 2 is 7. Okay, so this should be a 7, not an 8, right?
Okay.
So then 7, this should be an 8, correct? Now divide 23 23,800 by
Oh,
8.
okay.
Maureen, what do you get?
23.
What do you get for the mean? Two, 23.
27.95.
You got one?
27.75.
23. Do it
Yeah.
again, Maureen. I think you made an error somewhere. You using your calculator, or you doing it by hand?
Okay. It's 23.
23,800 divided by 8. What do you get?
2, 3. I get 2.975.
You get what? Say it again.
2.795.
Not 2 point now. These are thousand. So what do you get?
I will make calculator tell me.
You put 23800 and you divide it by
Yeah.
8. And what do you get?
Divided by 8 into, you get 2.975.
That's right, not point. The point comes after the 5, right? 0.00. So the mean is $2,975. All right, so let's just put, and let me just put this all over on this page, and let's put our mean there. Mean is $2,975. There's the mean, 2,975. And of course, that's dollars. All right, Maureen. Now, we've got the mean. What is the mode?
What is
The number that
No.
appears more than any of the others. Is there a number that appears more than any of the others?
No.
So what's the mode?
No more?
No mode. Very good. There's no mode, right? No mode. Okay? Because they all appear one time. Now, Maureen, we want to do the median. So what do we have to do to get the median?
We go from the highest to the lowest.
Okay, so let's just put them in order. They have to be in order for the median. So let's just put the what's the highest number of these amounts?
9,000.
Something bigger than 9.
10,700. No, it's 34,500.
No. You're looking at these investment amounts, Maureen. What's the largest of these investment amounts? You're looking at least 8 investment amounts. What's the largest number?
100,000.
No, you're looking at 9,000, 6,000,
Yeah.
7,500, 12,000, minus 2,000, minus 3,200, minus 4,500. This should be a comma. And minus 1. Which one is the largest?
9,000.
There's something larger than 9,000. Is there a number here larger than 9,000?
I don't know. They got 4,500.
That's a negative. That's a negative. Maureen, say your positive numbers. Just tell me the positive numbers.
9,000, 6,000, 750, 12, and 2.
7,500. 12,000. Which one is the largest?
12,000.
12,000. That's right. That's your largest number. So let's put it here. 12,000. That's our largest number. What's your smallest number? Your smallest is going to be one of your negative numbers. So what's your smallest number? Remember, the bigger the
1,000.
What is it?
1,000.
No. The larger your negative number absolute value, the smaller it is. So what is your smallest number?
Oh, this number is 1,000 because of 1,000.
No, that's a negative. Remember your number line? The minus 1,000 will come before, say, a minus 2,000, and you're getting smaller. So what would be your smallest negative number?
6,000.
6,000 is positive. What's your smallest negative number?
3,200.
No.
Oh boy, I don't know.
4,500.
Oh,
Yes, that's your
that's
smallest.
smaller? Wow.
Yes, because remember when you're looking at your number line and you're going from, say, right to left, you're getting smaller. So remember, just think if you had a -1 going from right to left, then you have a -2, smaller, -3, smaller, -4, smaller. So even if it's thousands, -1,000, smaller, -2,000, -4,000, smaller. Right? Think about your number line. A -4,500 on the number line would come after a -1,000, just like a -4 comes after a -1. Got it? So your largest number is your 12,000. Your smallest number is your -4,500. Now let's just fill in where the other numbers go. What comes after 12,000? Now you're still looking at your plus numbers. What comes after
9,000.
That's it. Very good. So 9,000. And after the 9,000, what's the next one?
750.
7,500. Okay, and the next one?
6,000.
6,000. That's it. Very good. Now, I think that takes care of all of your positive numbers, right? So now you're looking at the negative. We've got our smallest one. So what's your biggest negative number? Maureen,
3,200.
No. Remember, I just told you the number line. The 1,000 comes before the 3,200. So what's your largest negative number?
Largest would be 2,000.
6,000. Your largest negative number would be what? Here are your negative numbers: -2,000, -1,000, -4,500, and -3,200. So what's your largest negative number?
2,000.
No, there's one larger than that.
1,000.
1,000. Yes. 1,000. Remember the number line. Okay, let me just, okay, well, let's go ahead and finish this and then we'll put a number line up. 1,000, what comes after the 1,000, Maureen? What's the next one?
2,000,
That's it, very good, 2,000. And the next one is what?
3,200.
That's it, 3,200. And of course, we said the smallest is the 4,000, the minus. This should be a minus. And the minus 4,500 is the smallest. So let's just bring that back up here. Okay, minus 4,000. Okay, so we have them in order from high to low. Now, Maureen, how do we find the median?
Okay.
We have an even set of numbers.
Yeah.
So where would our median fall? Between what two
And
numbers?
the 6,000 beyond.
The 6,000 and the minus 1,000. That's right. Because you have three investment amounts in front of it and three behind it. So your median would be an average of these two numbers. So let's just make that bigger so you see it. Okay, so that means you've got to add the 6,000 and the minus 1,000 and divide by 2. What does that give you, Maureen?
3.5.
No, you're talking thousands here. How could you go to 3.5? You're adding 6,000 plus, this is a minus
3,500. What you say? 35, right?
What is 6?
I divided 7,000 by 2.
What is 6,000 and a negative 1,000, Maureen? What does that add up to?
A 7.
You're right. No. Unlike signs, you subtract. And you're right. You divide this by 2. Okay. So what's a 6,000 and a minus 1,000, Maureen? What does that add up to? You got to subtract because the number signs are different.
5,000.
So, that's right. It would be 5,000. So this would be equal to 5,000. Divide that by 2, and what do you get, Maureen? Mental math. 5,000, half of 5,000 is what?
25.
How much?
25,000.
In 2,500,
500.
right? So this would be equal to, let's see, let's back up. So that would be equal to 2,500, and that's the median. Right? So you got the median. Let's put it here. That's 2,500. All right. Now, how do we find the range, Maureen?
The range is from the highest to the lowest.
It's what?
The highest to the lowest.
No, it's not highest to the lowest. Range equal highest minus lowest.
Right. Well, the lowest is 1.
What's the highest number?
12,000.
12,000. That's right, because we have them in order. What's the lowest number, Maureen? They're in order.
1,000.
No.
1,000.
No, they're in order right here. There's the high, there's the low. So what's the low? Maureen,
1,000.
what is it? What's the
1,000.
lowest?
The lowest number is 1,000.
No, Maureen, they're in order here. High to low. There's the highest, and they're decreasing order. There's the lowest. So what's the lowest?
Or 500.
Minus 4,500. So this would be a minus 4,500, right? 4,500. Okay, Maureen, what is that equal to? What's a 12,000 minus a minus 4,500?
Okay, that's supposed to be.
Minus
2,000.
gives you a plus. No, minus give you a plus. So what's 12,000 plus 4,500?
16,500.
16,500. Very good. There we go. That's our range. So now we put our range 16,500. Now, I think we're still having a problem with the negative and positive numbers. Now, let me just put here, let's see if I can draw a line. Okay, let me just put a line here. Now, if this is the number line, right? Now, in the middle, we have a 0, right? Okay, we have plus over here and minus over here, right? Now, this is a -1, right? Let's put -1, -2, right? And if we keep going, let's say right here we have a -5. Let's see. That's a -5. Okay, now on the right, we have positive numbers. So this, after the 0, we said these are plus values, right? So +1, and we'll put a +2. All right, and let's see, let's put a +5 over here. Now, on the number line, Maureen, which direction, left to right or right to left, is an increase? Which way?
Right.
Okay, let me just put here increase. Okay. In other words, the numbers are getting larger. Okay, so for increase, now, do we go this way or this way? Now, this is from left to right. Okay, so I say L to R, left to right, all right? Going from this direction would be right to left. So this is an aura, left to right, and this is right to left. So Maureen, I ask you, which one is increase? L to R or R to L?
L to R.
L to R, that's an increase. So that's L to R, that's increase. That's the way I want you to figure out the negative numbers, while that bigger absolute value was actually smaller. So now we say decrease. Decrease would be from right to left. So this would be from right to left. Now, if that's a decrease, Maureen, we're going from right to left, decrease. So what is smaller, a -5 or a -2?
Give me a minute, Miss Barbara.
Okay.
Okay, like I said, down by my CPU, I do something from my computer. Okay. Well, I Miss, I can put you on mute for a little while.
Oh, okay. You're going to mute. Okay. Where did Chastity go? Chastity left. Chastity, where are you? You left? Yeah, the number line is a good visual representation of how you show that the negative numbers are smaller. Even though the absolute value may be larger, the number is actually smaller. In other words, a -5 is smaller than a -2. Because on the number line, as you go from the right side of the number line to the left, that's a decrease. Whereas an increase is going from left to right. So the minus numbers are all smaller than 0. 0 is smaller than the positive numbers. So that means the positive numbers are greater than 0. So you got to visualize how the numbers are smaller. And you can do that with a number line. So you should always be able to reproduce this number line and keep it visual to show that the negative numbers, even though the absolute value, because the absolute value of a -5 is a 5. So even though this is bigger, the -5 is actually smaller than a -2. Maureen, are you there? Maureen, are you back?
Yeah.
Yeah, I was saying you should be able to reproduce this number line. In other words, draw a line, put a 0 in the middle, put positive numbers on the right, negative numbers on the left. And even though the absolute value is a number without a sign. So the absolute value of a -5 is just 5, just like the absolute value of a +5 is just 5. Okay, so even though the absolute value may be bigger, the number is really smaller. A -5 is smaller than a -2. That's why when we were putting them in order, the -4,500 was smaller than the 1,000. Just say this was 1,000 here. -1,000 is bigger than, say, a -5,000. Got it, Maureen?
Yeah.
Yeah. So I want you to be able to draw this number line and understand it, because it'll help you in combining your positive and negative numbers. Okay.
Yeah.
All right. Now let's go to a new share. And I want to go to what we will be looking at today. Let's see. Okay. Now I want to look at some more graphs and charts before we look at the radicals and the exponents. So let me go back up here to our charts, our graphs.
Get over there. She got there, Shirley. Yeah.
Okay. All right. Let's go to, all right. Now, all right. There was one that I went over before, and I want to look at it again, Maureen, the scatter plot. That was one graph, and I mentioned it last time, but I want to look at it again. Now here's a scatter. Maureen, are you talking offline? Maureen, you have to go to mute if you're talking to people.
Okay.
All right.
Okay. We got to mute for a minute.
Okay.
Okay, I'm back.
Okay, now I'm showing an example of a scatter plot.
Uh-huh.
And this data is for some online stores, the sales and the advertising costs for the year. Now, here's the scatter plot. And all it is some points plotted on a line graph, all right? And what we are interested in is what we call our line of best fit. So we plot these values, and this is online dollars versus the monthly sales. And then we draw a line, and when you draw the line to get the best fit, you draw a line that touches as many of the lines as you can or come close. Okay, and we call that our line of best fit. Okay, and that's for a scatter plot. And basically, when you give them one of these, you should know what, and this is true of any graph, you should know what the graph is, and you should know what or being compared. In other words, you dollars and monthly sales. So monthly sales here is 400. If your dot was right here, that would be the dollars 1.5 for advertising. Okay. And they use this for making predictions. Companies use this a lot for making predictions as to what will happen based on past data. Okay, now, just another thing about bar graphs. The bar graph we looked at before was a horizontal. Here's a vertical. And this vertical graph shows median scores for high school. All right. And they've got the names of the high schools and they've got the median scores. Now you read them off at the top of the graph. So for this high school, the top of the graph is like slightly above 74, but it's not quite at 75, right? 75 would be midway between 74 and 75. And then when we look at this high school, it's between 68 and 70. It's a little above 69 because 69 would be halfway, right? Now, for this graph, Maureen, I want you to just look at those graphs and answer the question.
Which of the following questions can be answered about
Cannot be answered.
cannot be answered about the math score of the high school and examining the above graph.
So look at the questions and tell me which one cannot be answered from this bar graph.
Okay.
What was the difference this year between the median math score of the highest performing school of the 5 and that of the lowest performing school? Could you answer that from the bar graph, Maureen? Difference you get from subtracting. Can you get the difference between the median math scores of the highest performing school and the lowest of these 5 schools?
Not really.
You can't?
I just tried to figure out what was the difference.
Now, here's the highest performing school right here, right?
Yeah.
Highest median score right here, like a little above 74. Now, the
Yeah.
lowest one is this one. That's about 65, right? Now, can we get the difference between those two?
Yeah.
Yes, we can. We can take this score and subtract this score, and we got the difference,
Yeah.
right? So we can answer A. Difference, subtract the lowest performing school score from the highest performing school score. All right. Now B, Maureen, read B and tell me, can you answer B?
Of the 5 schools,
which school's median math score was the lowest this year? Can you find that?
This year was between 64 and 65.
No, the schools. See, there are 5 schools. School 1, school 2, school 3, school 4, school 5. Now, if I say this is 1, 2, 3, 4, 5, which school had the lowest median math score? Just give me the number. I'm calling this is 1, 2, 3, 4, 5.
The first one had.
Yes, you're right. Number 1, because its bar is shorter than the others. So that school had the lowest for the year. Okay. Now let's look at C. Of the 5 schools, which school's median score improved the most from last year? Can you answer that?
That would be between 70 and 72. This is that good the most last year.
Can you answer that question?
There's the one between 74 and 76.
No. Now, these school districts represent 5 high schools that took the exam this year. So this bar graph represents the scores for this year. Now, can you answer the question of the 5 schools, which school's median score improved the most from last year? Can you answer that question from that bar graph?
No.
Why?
Because all of them is the same thing as we start.
Say again what you just said, Maureen.
Because all is the same as we start. But nothing improved for the one is between 64, that didn't improve, the other one didn't improve, that didn't improve.
No. The reason you can't answer that, Maureen, is because you only have a bar graph for this year. You don't have a bar graph from last year.
Oh, I see.
You see what I'm saying? You can't answer this question because you don't have a graph to show what the scores were last year. This is only for this year.
Oh, I see.
You see why you can't answer? So the answer would be C. Answer C. So you can't answer that question because you need another bar graph. You need a bar graph of the scores from last year. You only have this year's scores. Okay. So those are the kind of questions sometimes you ask about the graphs. You don't have the information to answer C. Now you can answer D. Of the 5 schools, how many had median math scores above 70?
No.
How many, Maureen, had math scores above 70? How many schools?
2.
2, that's right. The one here and the one here. Everything else is below 70. Very good, Maureen. So those are kind of questions, all right? Now, one other thing I want to look at. Sometimes you have graphs of 2, say, companies or 2 entities, right? In this case, it's 2 stores, all on one graph. But notice they give you a little legend here. The solid line represents store 1. The little dotted lines or space lines represent store 2. And so this is the sales data for 2 stores over an 8-week period. Now they're all on one graph, this line graph, right? Now, so you know the solid line represents store 1, right? These little dotted lines represent store 2. Question: how many more sales were there at store 2 than at store 1 in week 6? Now I put these weeks down here because you can't really see them here. So this is week 6. So for week 6, you go up here and that's what, store 1. And then you go up here and that's store 2. All right. So Maureen, let's just say, okay, we know that store 2, that's with the little the little dash lines. All right. So let's go back down to week 6. Week 6 is here. Go up to week 6. What was week 6? We'll say for
week 6 was 340.
Okay, so week 6, and that's what, store 1. Okay, so let's put store 1 for week 6, and you say that's 340, right? Now let's look at store 2 for that same week. Store 2 is still at week 6. That's week 6. Store 2 was what at week 6? Store 2 is the little dash lines.
Okay,
So
that is four, that is 380. Like 385.
what is it?
But it's more than 380.
Yeah, it's between 380 and 400, about midway, right? So what
Yeah,
would be midway between 380 and 400? 390?
yeah.
Okay. Let's see. 340, 390. Okay. So that would be okay. Let's put store 2, 2 for week 6 equal 390. What's the difference, Maureen?
The first is
What's the difference?
50.
50. So what's the answer?
B.
What?
B as a boy.
Okay, B. That's right. 3. So the answer here would be B. So let's put it here. Answer B. Because you got 390, and that's how we figured it out. Minus 40 equal 50. All right. Now, read number 4, Maureen. Tell me how would you answer it?
During this week, the store one experienced the greatest increase in sales from the week before.
During which week did store 1 experience the greatest increase in sales from the week before? Now, store 1 is the solid line, right?
Yeah.
So where would you say your greatest increase came? Here, this is store 1, the solid line. Increase, decrease, increase, 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 and then kind of leveled off.
What would be
So where would you say your greatest increase occurred?
and okay. Which week, right?
During which week did store 1 experience the greatest increase in sales?
Increase,
So from one
increase,
point
increase.
to the other,
And
where did
week 5,
you say 5? Okay. You're saying
increase,
5. 5 is right
increase,
here, and it went
increase.
to here. Isn't it something bigger than that? The greatest increase in sales from the uh, week before. Okay, yeah, week 5, you're right, because it said from the week before, because week 4 was here, and then it went up to here. So that would be week 5. That's the answer. So the week 5, it had the greatest increase in sales from the week before. 4 was at this point, and then 5 went to this point. So we okay. So those are kind of questions you might answer when you have 2 different line graphs showing 2 different things. Okay, and it's good for when companies are comparing performances. Okay. All right, now I just want to show you the vertical bar graph and the horizontal. We looked at some before, but for the same uh, data, number of visitors versus the month. This is the way you show it on the vertical, and this is the way you can show it on the horizontal. Just information, okay? Horizontal, vertical, same information. All right. You can also have, and then you have it on a table here. Okay. Now you can have side by side doubles, just like we had two line graphs on the same, on the same, back up here, where we had two line graphs all on the same coordinate grid, all right? You can also have, let me just show you here. You can have side by side graphs. And they give you a code so you know the red is the adults, the blue is the child visitors, okay? And not only can you have them side by side, and you still read them off the same. Like this would be a 300, that would be a 200, right? This would be about 500. This one is about 600, okay? And this one, a little under 700, and this one is 600, same as this one, okay? But you can also have them stacked, all right? So, but you still read from the top, like the red is a child, is the adult, so you read it off here, and then the child would be read off here at its top. So there's a top.
Let me then the adults would be 3 and the children would be 5.
Say it again, Maureen.
The 3 would be 300 red would be adults.
That's right.
And the 500 would be the children.
Okay, so what about May? How many children?
How many children there?
Yeah.
1100.
And how many adults?
5.
500. All right. What about June?
June is 700 for adults. And 13 for children.
Right. Good. Yeah. Just so you can read them. You read them off the top. Okay. Now I want to look at some exponents. Now, Maureen, you remember exponents, right? What's an exponent? What does it represent?
Power.
A power. And also, if I say 4 to the 3rd power, what does that mean?
You multiply 4 3 times.
That's it. Multiply 4 by itself 3 times. Okay. That's how many times you multiply the base. And the exponent has a base and it has a power, right? So 4 is the base and 3 is the power. All right. Now, when we use exponents, our value gets big really fast, right? Now, notice you can use this little caret to indicate power. Like 4 caret 1 is 4 to the 1 power, 4 to the 2nd power, 4 to the 3rd, 4 to the 4th, 4 to the 5th. Like you say, you just multiply the number by whatever the power. So if it's a 1, it's just the number 4. If it's to the 2nd power, it's 4 times 4, and 4 times 4 is 16. 4 to the 3rd, 4 times itself is 3 times. 4 times 4 times 4 is 4 times 16, and that's 64. Then when you get 4 to the 5th power, 4 times itself 5 times, and you got 1024. So your number really increases pretty fast. Now, you can also have what we call radicals, and we've looked at radicals. They look something sort of like a division sign, and within the sign for the radical, we have what we call the radicand. That's the radicand, and here in the elbow of the radical symbol, we have the what we call the index, and when you don't see anything there, it's a 2. The 2 is the default. All right. So if this is an 8 and this is 3, then the root would be what number multiplied by itself 3 times to give you 8. And that number is 2, right? So, okay. But if you don't see anything here, then that means that it's a 2, square root, right?
Yeah.
Now, the symbol we use does not have this this line. We just use this part of it. and that means the radical. That represents the radical also, and we put in it the radicand. Now we're going to look at some rules of exponents, the most important rules of exponents. And I think most of them you're familiar with, we've gone over them, but I want to go over them again. And here's a table. So whenever you raise a variable to the 1 power, you just get, or a number, you get back just the number variable or itself. So 6 to the 1 is 6. 100 to the 1 is 100. If you raise to the 0, that's the 0 rule. Any number of variable to the 0 power is 1. Whether it's 1,000, whether it's 100, whatever. If it has a 0 power on it, it's equal to 1. Negative exponent is reciprocal of the positive. We'll look at some examples. Product. When do we get product? From a multiplication. So when you multiply exponents, you add the powers. All right? Quotient, that's division. When you divide, you subtract the powers. Subtract the power of the denominator from the power of the numerator. And the power rule, where you're taking a exponent and raising it to a power, and that's a multiplication. All right. So now let's look at these in detail. I just put them here on the table, but we want to. But if you can remember these laws of exponents, it helps you in solving your problems, and it holds for whether the exponent is positive, negative, or 0. Now you probably see I use this little caret sometime to represent the power on a base. I can use that, or I can just put the power, and we'll see how that. And like 10 with a little caret 1, that's 10, or I can say 10 to the 1, same thing. So when you send me work, if you're having a problem putting your powers, just put the little caret there. That's on your keyboard. All right. Now, there again, I said, when the exponent is 0, answer is 1. Any number of variable raised to 0 power is equal to 1. 200 to the 0 is 1. Variable k to the 0 power is 1. So any number of variables to the 0 power is equal to 1. Okay. Now let's go to negative exponent. When the exponent is negative, it's the reciprocal, and reciprocal means you put 1 over the number and raise it to the positive power. So 5 to the minus 3 is 1 over 5 to the 3rd power. Product rule, multiplication. Multiplication, remember you have the same base here. The bases must be the same for the product rule. The base is 4, exponent 2. Base 4, exponent 6. Add the 2 powers, 4 to the 8. Now, to show what this actually looks like, 4 to the 2nd, that's 4 times 4. 4 to the 6th is 4 times itself 6 times, right? And this, when you add this, you have actually 8 fours, right? And when you multiply them by themselves, you get 4 to the 8. The simplified form, 4 to the 8, which is 4 times 4 times 4, and then 4 times 4 times 4, up to 8 fours. Quotient rule, very similar to product, except it's a division, and you subtract. 5 to the 6th over 5 to the 3rd, 5 to the 6th minus 3. Subtract the exponent of the denominator from the exponent of the numerator, and you get 5 to the 3rd. Now, you could expand this. 5 times itself 6 times, right? divided by 5 times itself 3 times. And if you cross out all the 5s in the denominator, what do you have left? So you cross out a 5, 5, 5, and you have 5 to the third. So that's the way you can do it in the expanded form. Now the power rule, like I said, you have a power raised to a power, and that's a multiplication. So 9 to the third raised to the 5th power is 5 times 3, or 9 to the 15th. And if you expand this, you take 9 times 9 times 9, and then multiply that by 9 times itself 5 times, and you'll get 3, 6, 9, 12, 15 nines. Okay, 9 to the 15th. So those are your rules of your exponents. Maureen, you have any questions on them? I mean, we've done them, and I think you probably understand most of them, but I wanted to go over it with you and do some examples. Any questions, Maureen, on any of the rules?
Really?
Okay, well,
I think
let's
it
just,
understand it though.
okay, well, let's just go through some examples. Now, how would you write this as an exponent, Maureen? 6 times 6 times 6 times 6. How would you write that as an exponent?
Okay, let me see. I don't know. 6. 6 to the
6,
power 3.
but you're multiplying it by itself 4 times, right?
And 6, 6 is there. 6 is 6.
Be 6 to the power of 4, right?
Oh, I see. Yeah.
Yeah, because you're multiplying it by itself 4 times. So the
Yeah.
power would be to the 4th power, 6 to the 4th.
Oh, yeah.
Okay. What about this one, simplest form? That's a multiplication. You add the exponents. 8 to the third times 8 to the second gives you what?
8 to the 5th.
That's it. Add the 3 plus 2 and you get 5. Okay. Now here's a division. What would that be equal to, Maureen?
Yes.
Remember, you subtract the exponent of the denominator from the
That'd be
exponent
9.
numerator.
That'd be 9 to the power 3.
What's 7 minus 10?
3.
No, it isn't. 10 minus 7 is 3. What's 7 minus 10?
Minus 3.
Minus 3. So you'd have 1 over 9 to the minus 3, and that becomes what? 10 minus 7 is 3. Okay. So that would be
93rd.
7 minus 10 is
Minus
a
3.
minus 3. If this were 10 minus 7, it would be 9 to the third. But this is 7 minus 10. So it would be 7 minus 10 would be a minus 3.
And that 1 from, and then that 9 from 10.
No, you don't take 9 from 10.
Oh.
7 minus 10 is 1 times 9 to the, wait, just a minute.
Oh. Okay, 9.
No, 7, numerator, exponent minus denominator. So 7 minus, well, 7 minus a minus 10 is a 3. Because remember, you're subtracting, right? Let me just put this here. Okay. So you'd have 7. Let me just take that. I don't need the. Okay. So you have 7, let's see, minus 7 minus 10. Okay, 7 minus 10 is a minus 3. Okay, so that would be 7. 7 minus 10, 9 over 9 is 1. So 7 minus 10 would be 7 minus 10 would be a minus 3. So let me just see. Don't need this. So 1 over 9 to the
9,
minus 3.
Salford.
Now, if the 10 was here, it would be 10 minus 7, and it would be 9 to the third. But since the 10 is in the denominator, it'll be 1 over 9 to the third. Okay. Which is different from if it was 9 to the 10 over 9 to 7 would be 9 to the third. And since it's reversed, it would be the reciprocal of 1 over 9 to the third. Reciprocal of 9 to the third, which is 1 over 9 to the third. Now, here's the product rule. What do we do with the 5 and the 6, Maureen?
You got those?
Multiply. No, multiply. That's the power rule. A
Oh,
power raised to a power. So you
yeah.
multiply 6 by 5,
5 is
and you
30.
get 30, right? So that's a big number, 3 to the 30th power.
30 and follow.
Yeah, 3. That means 3 by itself 30 times. Big, big number. You have to do that on the calculator. Now, I just want to quickly look at radicals. Now, we can add, subtract, multiply, divide, and simplify radicals. Okay. Now, we combine radicals just like we combine other expressions. You know, like you can add and subtract. Like when we were working with variables, if the variables were the same, we could add them. So if the radicals are the same, you can add them. Like this example here, you given these, you want to simplify by combining like terms, but you should put them all in order. So like you put, like you see square root of 3, square root of 3 to the third, square root of 3 to the third. Okay, so square root of 3 to the third. So you put them all in order, you can add them, because the reason you can add them because you have coefficients, just like you say, let me just give you an example. Okay. Maureen, if you had, suppose you had 3x plus 5x, and I'll put a square on this one, second, plus 7x plus 2x. I'll put the second. All right. Plus 9. What would you say that's equal to, Maureen?
Okay.
Remember, I can combine like terms. So what would I say that's equal to?
Okay. That's 7x, 3x, and 9x, right?
What would you have?
I will say 5x to the power 2 and 2x to the power 2 is combined, right?
Yes, that's right. They like terms. So what would that give you?
That would give me 7 to the power 4.
Oh, no, 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 no. It'd just be 7x squared. You just add the coefficients.
Yeah, okay.
All right. You don't add those exponents. You only add exponents when you multiply.
Okay.
So this would be, let me just put that there. That would be, you said 7. That would be 2x the second plus 5x the second, and that would give you 7. Okay. And what else would you have? Anything, any other terms that are like you can combine?
And then you got 3x,
Mm-hmm.
7x,
And what does that give you?
5x.
That's it. Very good, Maureen. And the last one is a constant, and that would just
That's
be
9.
what?
That's 9.
That's just 9 because we only have it. So just as you added those terms, we can do the same when we have the same radicals. So let me just copy that here. Because I want to use the analogy there, like when we combine the same terms, like same variables, we can do the same with the radicals. So if you had like let's see, 8, let me put 8 here. Okay. 8, and let me put plus 12. I add the coefficients, Maureen. So if I combine these radicals, what would I get? Add the coefficients. Coefficients are the numbers in front of the radicals. So what would this give me, Maureen?
That would give 5 and 5 is 10.
No, no, no. You combine the coefficients.
Oh,
8 and the 12. Because notice up here, you combine the coefficients. You combine the 5 and the 2, right? So the coefficients are the numbers in front of the radicals. So what's 8 plus 12?
20.
20, right? And then you just repeat the radicals. So let's just put it. So that would be 20 times the square root of 5. You can do the same for subtracting. All right, suppose I had, let me just copy this and give you a subtraction. Okay, tell me what this would be. Now you have 6, and this is minus, instead of plus, I want a minus. 6 times the square root of 5 minus 2 times the square root of 5. What do I get?
4.
4
Square
what?
root 5.
That's it. Very good. Because 6 minus 2, that's the coefficient, right? And I have square root of 5. There. 4 times the square root of 5. So you can do adding and division. We'll look at multiplication, division later. We can do adding and subtracting of radicals just like we do with other expressions, right? You just remember it's the coefficients, and you can do this when your radicals are the same. And that's where the simplification process come in. We simplify our radicals to make them the same so we can combine them with addition or subtraction. Okay. And that's what I said. You must simplify the radical. Some problems you have to simplify the radical before you can add or subtract. And I have some examples here. We just did some. 2 times the square root of 5 plus 6 times the square root of 5. Add the coefficients 2 and 6, get 8. Right? Now, this one, which radicals are the same in this one, Maureen? Number 2. Which radicals are the same?
Okay. Yes.
Which radicals are the same here?
B. That is a B, right?
Which one does it say? The square root of B. Yeah, you have it here and you have it here, right?
Yeah.
So what's a minus 5 square root of B and a square root of B? Let me just put that here, because those have the same square root of B, right? So let me just put that there. And I have plus, and there's the square root of B, right? Now you're adding this, Maureen. What is that equal to?
6.
Oh, signs are different. You subtract.
4. A minus 4.
Minus 4. So there's my minus 4 that I got right here, right? So take my minus 4. Is here. Okay. That's how I got my minus 4. And then I just put my 6 times the square root of 2b because I don't have any square root of 2b to combine that with, right? So I
Yeah.
just want to show you how we got the minus 4 times the square root of b. We combine the minus 5 square root of b and the 1. Remember the default is 1. 1 times the square root of b. Remember, still keep track of your signs. You have a minus and a plus. You subtract and you get a minus because what? The largest absolute value has a negative. That's the 5. Questions? Okay, now here is one. Remember I said sometimes you have to simplify. Now, you cannot combine these, Maureen, because what? They have different radicals. They have different radicands, okay? You have a 12 here and a 3 here. But you can factor the square root of 12. Just like you factor 12 in the 4 and 3, you can factor the square root of 12 into square root of 4 and square root of 3. All right. Now, if we do that, what does this become? Let me just copy this. Maureen, you tell me what this is equal to. I told you what the factor is for, right? So what would this be equal to?
6.
No. The square root of 12
It's 4 and 3.
is, yeah, is square root of 4 and square root of 3. So what would I write here and put my factors in? What would this look like?
Square root. 4 square root 3.
No, you got a 2. You can't throw that away. You got a 2. And what goes behind it? What's the factors of the square root of 12?
4 and 3.
Yeah, so did I put that? Take this and put it here. So 2 times the square root of 12 is 2 times the factors of square root of 12, which is square root of 4 and square root of 3. Now, Maureen, what do you think you do next?
The plus.
What?
Then you put a plus there.
No. What is 2 times square root of 4 times square root of 3?
Square root of 4 and square root of 3.
I wrote this. Do you see anything there that has a perfect square root on the right side?
Hello?
What do you see?
Got 2 into 12.
No, let's look on the right side here. This 2 times square root of 12 is equal to this expression. What's the square root of 4, Maureen?
2.
2. So we can take the square root of 12 and put a 2 here, right? Okay.
I see.
Okay. Now what's 2 times 2?
4.
4. So 2 times square root of 12. Let's just put top of that again. And 2 times 2 is 4. Okay. So that would be 4 times the square root of 3, right? Now I can go back up here, Maureen. I already have a 6 times the square root of 3, right? And I said the 2 times the square root of 12 is 4 times the square root of 3. So let's just put that there. And the 2 times the square root of 3 is 4 times the square root of 3. So let me just put that there. We've already got that. Okay, so that's 4 times the square root of 3. And I don't really need the parentheses here, right? Plus 6 times the square root of 3. So what's that equal to, Maureen?
6 to the square root of 3.
Yeah, what? 4 times the square root of 3 plus 6 times the square root of 3. Add the coefficients. What do you get?
6.
No, the coefficients are 4 and 6.
2.
No, 4 plus 6.
Or 10.
10. So that would be 10 times the square root of 3.
Oh, I see.
Remember I said sometimes you've got to simplify your radicals in order to add or subtract the radicals. See, I can't add a square root of 12 and a square root of 3, but we can factor the square root of 12 into square root of 4 times square root of 3, and the square root of 4 is a 2. So now I have 2 times the square root of 12 is 4 times the square root of 3. And I have a 6 times the square root of 3. So I can combine those coefficients, the 4 on the square root of 3 and the 6 on the square root of 3, and get an answer of 10 times the square root of 3. Maureen, is it making sense?
Yeah.
Yeah, you remember you factoring, you just like you factored before, except you're factoring the radicand. So just like you say 12, I can multiply 4 times 3, square root of 12, I can multiply square root of 4 times square root of 3. Now, just to, okay. Now, Maureen, suppose I had, let's see, square root. Let me just put here. I want to put a square root. I want to see if you can factor it. Okay, let me put this here. Okay. Now let me put 48. Now, square root of 48 doesn't have a perfect square root, right? Right, Maureen?
Yeah.
Now, what two factors can you multiply to give you 48? One has a perfect square root.
3 and 16.
3 and 16. Very good. So that means you could take this square root of 48 and write it as square root of 16 times square root of 3. Very good, Maureen. Okay, so that means we can take the 16 and put it here. Okay. And put the square root of 3. And what's the square root of 16, Maureen?
4.
4. So then you have equal. And let's just copy this and put our 4. So square root of 16 is a 4. So let's just put that square root there. And that's it. That's the simplification of the square root of 48. Got it? Yeah. And these are square roots that you know. You know, we have examples where you know the square root. Okay. So the simplification of the square root of 48, answer 4 times the square root of 3. Okay, Maureen, we're gonna stop here. Your
Okay.
homework will have some, well, we'll have some graphs, and we'll have just some exponents where you use the rules for your multiplication, division, and then I'll give you a few radicals to simplify, just like I gave you square root of 48, right? A few radicals for you to simplify, okay? Any questions on anything we've gone over, Maureen?
Nah.
I don't know what happened to Mercedes. She was supposed to come on. She probably was sleeping. Okay, Maureen, so I'm going to
All
say
right,
so
so
long.
good. Have a good weekend.